Good morning, or good afternoon, or good evening, depending on where you're tuning in from, and thank you for joining us for today's webinar with DotProduct and Ship Architects on de-risking tugboat engine mods with handheld 3D scanning. This is Chris Ahern with DotProduct. I'll be the moderator for today's session, and we'll be passing it off shortly to Tom and Josh with DotProduct and Ship Architects to introduce themselves and lead you through today's presentation, as they were the primary on this project. Before we get started, I just wanted to make you aware of a couple notes. We encourage you to ask questions at any point throughout the session. You can submit them directly through the chat bar in your GoToWebinar window, where you'll see the option to send questions to staff. We'll address as many of those questions as possible live at the end of the session, and we'll make sure to follow up with everyone directly via email afterwards as well. In addition, I want to make you aware that we will be recording this session and we'll be mailing it out to each and every one of you as a video recording by the end of the week. With that, I'm going to go ahead and pass it off to Tom to kick off our presentation and live demonstration.
Thanks so much, Chris. Welcome, everyone. We have more than 150 people registered for this webinar, and absolutely delighted to have you. Let me just begin with a short introduction to DotProduct. We're a young software company headquartered in Boston, and we have a development office in just outside of Frankfurt. You can see the management team on my first slide here. On the left is Raphael Spring, our Chief Technology Officer, and the software that you're going to see a little later in the presentation was designed and created by Raphael. He's a computer vision expert. He used to work for Google on the Google Glass and Google Goggles project and some other projects. Brian Ahern is our CEO, and Brian is ex-Trimble. Brian and I both have been around the point cloud business for the last 2 decades. So that's me on the right, and I head up sales, marketing, and customer support for DotProduct. Before we launch into the project itself, I'm going to tell you a little bit about the history. I met a gentleman by the name of Pat Roberts at SSI, Ship Constructor Software, at the Offshore Technology Conference a few years ago. And Pat introduced me to Ship Architects, and we're going to be hearing from Ship Architects in just a minute. And we got to talking about how scanning could be applied to shipbuilding, ship repair, ship maintenance, for those kinds of applications. And this led to an NSRP project called ShipScan. And in the course of that project, getting ready for it, I met Josh Trippy from Ship Architects, and Josh is joining us on this presentation as well. So Josh and I met up on a push boat outside New Orleans, and that's where it all got started. So thank you so much to NSRP for funding this ShipScan project a couple of years ago. We're seeing adoption in the shipbuilding, ship repair industry. So let me turn it over to Josh to introduce himself.
Thanks, Tom. Hey, everybody. My name's Josh Trippy. I'm the Director of Engineering here at Ship Architects. We're a small naval architecture company down on the Gulf Coast, down in Daphne, Alabama. And the company's been around since 1999. I've been here as part of the company since 2007, and I've got a background in mechanical engineering. Ship Architects offers a number of different services, all kinds of naval architecture things, ship stability, class calculations for structure and piping systems for ships, dry dock inspections, blocking plans, any of the typical naval architecture services you would expect. Also, a large part of our business is focused on 3D modeling for detailed production design, using Ship Constructor software, like Tom mentioned, SSI. We utilize this for new construction builds, as well as some retrofit. So we'll show you a little bit of that today. I want to give some credit here to Matt Coombs at Christian Gray for getting us involved in this project specifically. His team selects and supplies the rubber isolators for projects like these that we're going to show. We've had a good working relationship with Christian Gray for the last few years, and Matt's been getting the ball rolling on a few of these projects for us. So eliminating vibrations on these workboats makes for a much more comfortable crew environment that these vessel owners are going for. So we'll show you a little bit about what goes into making these modifications today.
All right, thanks so much, Josh. We'll get started with the content here. Let me advance the slide. There we go. So this is the tug, the Mount St. Elias. It's a 95-foot high tower barge tug operated by Kirby Offshore Marine, and twin diesels, which we'll get to in a minute. And so the way this worked, Kirby engaged ship architects to design some engine mount modifications to reduce the noise and vibration, and ship architects engaged us to provide some as-built capture services using our handheld 3D scanning solutions. So preparation is key for the success of any project, and I just want to review some of the preparations that we made and to get ready for it. One of the key things was getting on the boat when it was in port, and we wanted to show up in time to get on the boat, but not hang around the port too long. So Josh suggested we use marine traffic for scheduling, and I'm just going to pull up a marine traffic window here. So we were able to monitor where the boat was. This is where it is today, in the middle of Long Island Sound, headed back to New York. So very useful thing about marine traffic is you get an estimate of its arrival time. So we started following this about 12 hours before the project, and it was very, very helpful to be able to just get to the job site on time. We were in New Haven, Connecticut. So that was one thing. The next thing I'll mention is PPE. The usual boots, hard hat, and in this case, because it's a marine project, we each needed PFDs. They were supplied by Kirby. Very important to have hearing protection. We were down in the engine room. I think it was probably 85 dB thereabouts. Very loud environment, and down there for a couple of hours. So very important to have good hearing protection. This is something we didn't have when we did the project, but I got one of these afterwards. This is a TWIX. This is a transportation worker identification card, and it's a very good thing to have if you're working on these kinds of projects. Because these are controlled spaces, and this smooths access to the site. Very easy fairly straightforward to obtain too. So highly recommend it. The last piece of the project preparation was a review of the project scope and objectives. There were some access issues and just how we were going to set the data up. So we had several phone calls and conversations with Josh, reviewing what was key, what data they wanted to get, and what they were trying to accomplish. Essentially, we needed an as-built we needed to capture the data to produce an as-built of the engine girder structure. This structure was covered up by diamond plate, so we had to be sure to get that sorted out. When we got aboard the vessel, we worked with the ship engineer to get this diamond plate removed so we could see what the girder structure looked like. And then lastly, Josh and I had a discussion about what coordinate system we wanted to get the data in. You'll see in a minute that we were able to send a look at the data from the engine room back to Daphne, Alabama, so Josh could have a look at it, and we wanted to get it lined up approximately in ship coordinates. So this is us boarding the vessel and carrying our gear in a backpack, and this is a scale bar kit, which we'll hear about in just a minute. We provide a variety of solutions, 3D scanning solutions. This is a phone and a RealSense camera. The one we used on this project was a DPI 10 scanner with a light kit. That's the one in the middle. But they come in various shapes and forms. This is the one that we use. The DPI 10 has a Carmine short-range sensor on it. It's ideal for this kind of project. So here we are in the engine room. That's me with the scanner, and I'm going to just play a short video to show what the scanning process itself looks like. So there we go. This will take about 20 seconds. You can see we have a light to get into the, illuminate the shadows. And we just walk around the area of interest with the scanner. And I'll point out a couple of things here. There's the screen turns green and yellow as we capture the data. So the greener data is higher density data, better data. And the scene turns green as you get closer to the area of interest. And also, if you're at a right angle to the surface, the data quality improves. So we're getting real-time feedback as we collect the data about its quality. So we know what we have. And I'll show you some of this data that we collected in just a minute. The next thing I want to point out is, I'm just going to back up just a little bit here. Well, let me go back here. There's a scale bar here that we put in the scene. And it's a known distance from one end to the other. And we use that as a constraint when we do some post-processing on the data. It's just a check on the dimensional accuracy. We tighten up the data by using these devices, scale bars. And that's what I was carrying in. You could see that in the case in the first slide. So now I'm going to switch to the data. There we go. So this is our .3D application. And I've got this running on my laptop today. It also runs on Android devices, but I've got it on a Windows 10 machine. And this is the raw data, right as it comes, just as we collect it. And I'll point out a couple of things. So this blue Z-axis is pointing in the direction of that's the direction the camera was pointed when I hit start, okay, when we got going. And then the second thing I want to point out, if you look carefully, you'll see a little blur here, double target. That's all going to get fixed in the optimization, which I'm going to do right now. So we're going to start the optimization. We're using these coded targets for loop closure. That's a longer conversation, but essentially we use these as fiducials for loop closure, and we're using a scale bar kit as part of the optimization. So I'm going to start running that. We've got two scale bars in the scene. These numbers are a little bit more pleasant to look at when they're in millimeters, but we're working in inches on this project, so that's why they end up that way. So we're optimizing the scene here, and we're really doing three things. We're tightening up the alignment of the data that we collected, the frames of data. We are leveling the colors. You can see this purple on these cooling pipes here. That purple looks different from different angles, and we average that out in the post-processing of the data. We're also eliminating redundant points. We keep our file sizes small by eliminating redundant points as we collect them, and then also in the a few more in the optimization stage. In this particular case, we're integrating the control of this known distance between this point, one end of the scale bar, and the other. I think it's about 5,200 millimeters. These scale bar kits come in 1 meter increments, and you can screw them together. So that's another piece of it. The targets on the end of them are also used for loop closure. So if we go around the scene in the loop, which we always endeavor to do, we can wring out drift and tighten up the data that way. So that's the that's the data after it's been optimized. And you can see the blur is gone. I'll put it in point mode here. So we have two modes. There's a rendered mode and a point mode. And then what I can do is set this up in ship coordinates. So this is just going to be a crude alignment. So I go edit, coordinates, and we're going to set the coordinate system up here. So I'm going to pick the 0, 0, 0 point, and it's just arbitrary. We're just going to put it right down here on the diamond plate. And I want to get the z-axis up. And so we, in our conversations with Josh before going on board, we determined that the fuel tank underneath here had the top of the fuel tank would be a good reference for that. So we're going to pick that here. There it is. And it fits a plane to that top of that tank. And that we set Z to be perpendicular to that plane. And then next, we've got a bulkhead back here that we're going to use for the X reference. So I'll just pick a piece of the bulkhead here. And you can see I've got this magnifying glass to help me. Maybe I'll pick it down here. That's just a little better. There we go. So now X is going perpendicular to that red plane. It's going fore and aft. This is the aft bulkhead. There's a forward bulkhead up here. This is the aft end of the engine. This is the forward end. So we've got that roughly aligned in the right place. And so we'll just confirm that. And once we have the coordinate system set up, then we can do some things like take a measurement. So I can make a distance measurement here. I'm just going to pick a point here, and I've got a little magnifying glass in the upper right-hand corner. So I'll pick a point there and another one here. And that was a 48-inch section of diamond plate. They come in those widths, so that was cut up to fit in there. So we can take measurements. Another feature is that we can take high-resolution photos. So I shot these with the tablet camera, and I'm going to display them here. So you can see these purple icons. They correspond to the photos that are in the gallery in the right-hand side. And we can navigate through these by, we can click on the photo, and it'll take us to the place in the point cloud where we took that photo. So you can see these cooling elements here line up with the photo there. We probably took a little overzealous in taking the photo, so it's a little bit congested. But they allow us to see some detail. You can see details in the photo that you may not be able to see in the 3D. So if I do a long press on the photo, you get a very impressive level of detail with that camera. So you can read equipment tags and most importantly, though, you know where the photos are in the scene. The challenge with taking photos in an environment like this, well, first of all, it's really easy to get confused about which side of the engine you're looking at. And when you have twin diesels, which engine you're looking at. So keeping track of where the photo was taken is done automatically by our software. You just select where you want to take the photo, and it shoots a high resolution image. We can also add a photo. I took some photos with my cell phone, and I'm going to add them in. I'll add one of them in. So we're going to add a photo, and I'm going to say we want it to go there, and it's a photo. And I navigate to the port engine, starboard side. No, port side, sorry. Photos. Excuse me. I've got the wrong engine here. We want to go to the starboard engine. And we're going to look at the port side. And there's the photo I'm going to show. Okay, so this was captured on my cell phone, and I've got it right there. And I'll do a long press on that. And this is from my cell phone. So I was able to add this photo to the scene. The whole idea here is to capture some of this detail, for the engineers who need to be able to see, what's going on around this girder structure. Okay. So one of the things that our workflow enables is that we can send this data from the field back to the office. So this is about a 36 or 38 megabyte file. And so when we were about a half an hour into the job, I texted Josh and we set up a Dropbox link. I sent one of these files to him, and we had a little back and forth about some of the detail we were seeing and the specifics of the areas of interest. So this is a great thing about our scanner, that we can actually do this. We're not going to wait until we get back to our hotel room, send the data back the next day or that evening when the boat's already left a port. We're able to do it while the vessel's in port, while we're on the job site, while we have time to take corrective action. So I think that's one of the key values of doing this with handheld scanning, is that you can get that near real-time feedback from the field to the office. Okay, so those are just some of the features. We can measure, we can annotate, we can export this. The final step here is sending the data to the office in a form that can be used. And we exported the data as a recap file in this particular workflow, which can be attached to Ship Constructor and some other applications. And that part of it we'll leave to Josh to show in just a second. But the point is that you don't need to have recap on the boat. You just need to have our software, and you can export it directly from there. Okay. So with that, I'm going to go back to the PowerPoint deck. I think we've covered all of these issues here. And with that, let me turn it, the presentation over to Josh to show you what happens after the data has been collected. So over to you, Josh.
Thanks, Tom. All right, let me get my screen shared over here. Okay. All right, so I'm going to be presenting kind of what we did using Navisworks, which is an Autodesk product. We use Navisworks a lot as a viewing tool for the Ship Constructor data and models that we build, and it's a great tool for bringing in point cloud data when you're trying to view interferences with the points. Sometimes it's a little hard to see what's going on bringing the point cloud into an AutoCAD environment, but in Navisworks it's very easy to float around and see what's going on. So real quick, just to show sort of the concept of the project, we had modeled the section of the engine room that we were interested in with the 2 diesel engines and the engine girders, and what we wanted to find out was we knew we had to get some new isolation mounts underneath the engine between the steel girder structure and the engine. We didn't want to move the position of the engine up because that would cause a whole lot more complications that would have to be dealt with. So we decided we were going to move the girder down. And so, as I mentioned before, Christie and Gray had selected some isolators that they knew was going to work with this engine, and an arrangement of those. We worked with them to get the details of that. And so we knew where the engine foot was. We knew the height of the isolator mounts. And so we kind of had this distance we had to make up from the existing engine girder down to something lower. So we needed to come up with a new engine girder faceplate for these to mount on. And so any of this structure in here that we were going to cut out, we needed to use the scan data to make sure that we weren't going to get into anything that would cause issues. So let me go ahead and pull in now some, well, before I do that, as another note of the change, this is a photo of the existing mounts. This black rail here is part of the engine bed, and this is the existing top of the engine girder. And all they had was some adjustable mounts, but solid. No rubber isolation. So any kind of loading or vibration from the engine was getting transmitted directly into the ship structure. So this project was going to add this isolation between the two to reduce the vibrations to the hull. So now let's grab some scan data from Tom. We're going to go append, and we're going to go to a recap file that Tom exported for us. And so I brought it in, but as you can see, it's not laying here on the engine like I want it to be. Look over here, it's floating out in space, which is fine. That's what we expected. The good thing is that it is oriented up in the right direction, forward is in the right direction. So all we need to do with this data now is to simply slide it into position. So Dot3D also has some automated alignment tools. I could have sent this 3D geometry to Tom and put it in Dot3D, give it some constraints with the data, tell it to recognize some surfaces, and it does a pretty good job of aligning. At the time, we didn't have this model built yet. So what we've done is just kind of pick some points, X, Y, Z, to see where we need to slide things around. So I can see this forward bulkhead here, and I can just simply snap a dimension from that point back to this bulkhead, and it gives me an XYZ. So I know it needs to shift about 565 inches aft. I can also see the face of this engine girder. That will give me some kind of off center line dimension. So I can snap from there to the face of that girder, giving me a Y dimension. And as we mentioned before, there's a tank top down here. So I can snap to that, snap to this tank top, and somewhere around 75 inches is the Z that I need to move. So I can just grab this scan file, go ahead and shift it using Navisworks transform features. And I'm going to type in these magic numbers that I came up with off the fly, and everything's going to line up perfectly. So this is just shifting the data in the world coordinate system to line up with our model. Let me turn off my modified structure here for a second. And I'm just going to zoom in here. So one of the main data points we were looking for is to make sure we lined up this existing engine girder top plate. So you can kind of see the white painted point cloud lays nicely over our 3D geometry. You can see these flange plate brackets all have some scan data that lay right over the top of everything. So on this project, we were lucky to have some pretty good 2D structural drawings that allowed us to build this 3D model. So we had all of that information. We could build the steel structure, but what we didn't have was some of the outfitting and piping items. You can see all of this framework for the floor plating, the diamond plate support structure. We didn't have any information on that. Some of these smaller pipes and equipment foundations, we didn't have information on that. So the scan data gave us all of that without having to go through and try to dig for some location data that may not even exist. So we can see there's a fuel filter assembly here that's mounted on this existing girder. We'll need to address that in the new design. There's also some fuel piping that's going up to it. So if I turn back on our isolation mounts and our proposed modified structure, you can see with this larger faceplate, it now sticks out into the space a little bit. This pipe is going to have an interference. This support structure is going to have to be modified to suit the changes that we need to make on the engine girder. So we had 2 engines on this project. Each engine, we had an inboard and an outboard scan. So we repeat the process, kind of line up each of the 4 scans in the space, and that gives us a nice output to look at. This is going to alert us to any kind of interferences that we need to alert the shipyard and fabricator who's going to be doing the modifications. So from all of this data, we were able to put together a detailed engineered drawing on the modifications that had to be made. You can see this view showing the old engine girder with the 2 step-ups for the solid mounts. This is the new arrangement, which is kind of a tapered down and flat footprint. So we give them dimensions on exactly what to cut out, dimensions for inboard and outboard girders. And then this sheet, we were able to use the scan data that we'd collected and identify specific items in specific locations that would need to be addressed for the modification. In this case, talking with the owner, they didn't want to go ahead and try to modify the new structure to address some of these interferences because they thought some of these may be moving as part of the whole project modification. So we just identified them here and let the fabricators decide whether they were going to move the pipe or the electrical cables, or if they wanted to notch out the steel foundation that was going to get put in there. So each one of these, I'll zoom in a little bit. Each one of these little gray items indicates some sort of interference that we saw with the scan data that would need to be addressed. And then following some more details on the installation of the new plate parts, brackets, dimensions for fabricating all of this. And kind of a final view that shows the drivetrain alignment, the new isolator mounts, some details on the bolting, the Christian gray, model numbers, and the final arrangement. So once we had a design for the new foundation, we actually were able to utilize another NSRP project that we were a part of, which was called Lift Ship. What this did was streamline the process for getting the ship constructor 3D geometry out and into finite element analysis mesh data. So we worked with some of our other teammates on that project to get the data out of ship constructor into an FVA mesh. We were able to load the engine weight and torque and vibration characteristics onto the isolators in an FVA model and verify that the stiffness and strength of the engine girder modification was adequate. And so that has all turned out well. Ended up being a really good project. I think Kirby's got this pushed out a little bit due to some of the COVID virus issues we've been going through. But we're looking forward to getting them, get these engine girders modified and installed. And we always love to hear that we've done a good job and the ship is vibration free, or at least, minimized vibrations compared to what was there before. So we've got some plans to do a few more of these. Each one's a little bit different. So the modification is going to be different, but the process is kind of similar. Get some as-built 3D data of what's out there in the vessel. Make sure that we know what we're dealing with so that we can really eliminate any of the unknowns when you get into, being in the shipyard, actually cutting the parts out. We don't want to get into any surprises that could be costly and delay schedule. So that's kind of what we've done here. We were able to utilize this scan data to minimize the risks on this modification. So with that, I think I'll send it back over to Tom to kind of wrap things up. Let me swap over.
All right, Josh, thanks so much for that. That's excellent. Excellent. I'm just trying to minimize there we go. So just to summarize, on the scanning side, some of the benefits of this approach, the small data size that we produce allows the results to be shared from the field to the office for QA and QC, before you leave the site. And in our experience, this would be extraordinarily difficult if you did it any other way. If you had a tripod scanner in there and multiple scans, you wouldn't be able to turn it around that quickly. It's helpful to have the 3D data aligned to ship coordinates, so you can disambiguate what's what and how it's oriented. Because as I mentioned earlier, with twin engines, it's pretty easy to get confused about which engine you're working on, and if you got it all in 3D, that there's no confusion. Josh showed the workflow of getting the data into standard industry applications, Ship Constructor and Navisworks. I'll show a slide in just a minute about some alternative workflows. And lastly, the georeferenced images allow the 3D data to be supplemented with high resolution images for high levels of detail, and that has a place too. So our workflows, the ones we focused on today, were Autodesk related. The Ship Constructor is a AutoCAD add-on application specifically for ship design, ship construction. But we also work with some others, particularly relevant to to marine applications is Rhino for hull design, and we're in the midst of working on a workflow for Rhino and integration with DotProduct. We've got it working in Rhino. We're just streamlining that workflow, and we'll have a webinar on that a little bit later this year. So those of you who are interested in that, please follow us. So with that, we welcome the chance to field any questions. Chris, if you want to kick that off.
Absolutely. Thank you, Tom and Josh, for a very informative session. I've been collecting several questions along the way, and we'll take as many as we can over the next 10-15 minutes. So I can tackle a couple of questions that are pretty straightforward right off the bat here. First question is, will there be a recording available later? And the answer is absolutely. So we recorded this complete session. We'll be publishing it to our website and mailing it out to all registrants by the end of the week. Next question here is, what is the range for the short range sensor versus the standard sensor? And is there a difference in how they perform on surfaces without a lot of landmarks like a flat wall? So the range difference here is the short range model is a 1 to 6 foot range. So ideal for scanning equipment, like we're talking about here, objects, extremely tight spaces. And the longer range standard sensor model is a 2 to 12 foot range. And that's going to give you a higher visibility at longer distances, ideal for scanning room scale areas. And it will track better in areas without a lot of landmarks, such as a flat wall. And that's the nature of being able to see further, because, for example, you could be seeing the corner of a room while you're capturing that flat wall with the longer range model, while the short range model might struggle a little bit more on those sort of flat surfaces. Next question I see here, Tom. Could you please show the same point of view of the photo taken, but in the point cloud model? I think we actually did do a little bit of that live, but Tom, if you want to talk about
let me drill into that. We have two kinds of photos that we were showing here. Ones that were captured independently on my cell phone, and the others that were captured with the tablet camera, with the HD camera on the tablet. And the ones that are captured on the tablet are very closely aligned. There's a little bit of offset, but not much. So you get that automatic alignment. Let's see, perhaps I could show that. So I've got a photo here. And if I just back out a second, that's this one. And if I zoom in, you can actually see the structure I'm looking at. This piece corresponds to this piece, and this piece corresponds to this piece in the photo. And if we do a long press on the photo, we obviously get to see the detail. So they are aligned. The photos that we attach from an external source, let's say from a DSLR camera or from a cell phone camera, unless you put the camera in exactly the right place, they're not going to be aligned, but you can get them close. You can certainly position them. You may not be able to get the orientation correct.
Great. And I'm just collecting a few more questions that have started coming in as we transferred into the Q&A session. So next question here for Josh. Do you align the multiple scans within Navisworks, or are there any advantage to doing this in recap and bringing in one contiguous scan? What did you do in this case?
In this case, we just lined them up in Navisworks. You could certainly bring each one of these up into recap and use its features to put it all together into one scan and line it up. Since we were really focused on kind of each individual side of the engines, we were more interested in kind of lining up just the very close points of the engine girder right under the engines. I guess we certainly could have cropped out some of the outlying points to help it line up, but in this case, using individual scans and just sticking them in Navisworks accomplished what we were going after.
Great, Thank you. A couple questions here came in about the scale bars that were mentioned during the video of the scanning, asking, where you choose to place those and what the benefit is of those bars.
Sure. So you want the scale bar running the longest length of the scene of interest. So you'll notice we have the scale bar running from one end of the engine to the other. And we got another one going at an oblique angle to it. But you don't want a bunch of short scale bars in the scene. You'll get undesirable results. You want to optimize over the length of the scene. And we're doing a bundle adjustment or least squares a fit here. You would prefer to be interpolating rather than extrapolating. So if I can wave my hands just a little bit and say what is ideal is to have the scale bars running the full length of the scene, ideally the full width too. But so if I had to do it again, I would have run the second scale bar at right angles. But no do-overs here. These scale bars can be, you can make your own, or you can buy a kit from us or from Brunson. The Brunson one is accurate to plus or minus a millimeter. That's the spec over, I think, 5 meters. It's very, very tight. These are made of Invar rods. They change very little with temperature. It's really a good solution. But not always, you got to carry them around, and the kit is heavy. One of our customers up at Bath Iron Works came up with a different scheme. They printed the targets on Mylar sheets and just unrolled them. And Mylar weighs a lot less than Invar. So when he was doing ship check, he would just unroll them and put them right in the scene that way. And if that's of interest, please let us know. We can make the targets available to you.
Next question is, which shipyard the tugboat in or involved with, I guess?
So I believe the ship was just in port. It was in operation when Tom went to get on board. So they had to catch it while it was in port, offloading some cargo. And that was in New Haven, Connecticut, I believe, Tom.
That's correct. It was in New Haven. I don't know where it was built, this one.
Sure.
Yeah.
I believe it was built in Thomasy down in Louisiana years ago.
Yeah, 2009, something like that. Yeah.
Yeah, I went through a conversion to add the tall tower portion to it.
Perfect. And Tom, I think this was touched upon at the beginning, but someone's asking which scanner was being utilized here. What was the hardware in your hands?
Yeah, so this was I thought it was a DPI 10, but it was actually a DPI 8 SR that I have with and it had a very nice light, the Fox Fury light kit on the top of it. That gives a really bright light, and it had the Carmine 1.09 sensor in it, so 0 to 2 meter sensor.
Absolutely. Question for you, Josh. What was the purpose of the modifications being made? What was the goal of the project for Kirby or for the boat itself?
So the purpose of the project, the owner had identified some excessive levels of vibration while they were operating, and they actually hired a company, AME, to come out and do a sound and vibration survey. They went and put sensors kind of all over the vessel at different points, measured vibrations and noises to get an idea of what some of the issues were. At the end of their survey, they made some suggestions on what they could do to resolve some of the vibration issues. One of the big ones was to change the engine mounts from a solid mount to a rubber spring isolator. So that's where we got into the project. To do that, those rubber spring isolators are a good bit taller than the current solid mounts. So there would have to be some structural modification to the engine girder to be able to fit those in.
Got it. Thank you. Next question, Tom is asking about the actual scan process. So noting that you did each engine, each side of the engine as a single scan, rather than going a full circumference around the engine in one scan. Sorry, two instead of one. And the question is, was that for accuracy or due to access with the deck plates, or otherwise? What's the reasoning for breaking it up like that?
Yeah, that was primarily driven by the access issues. So we had the diamond plate lifted up, and so it was kind of tricky walking around those surfaces. One of the safety concerns, this scanner can be operated with one hand. So, one hand for the scanner and one hand for the ship is kind of the rule. But even so, it was tricky navigating from one end to the other. So I just broke it up that way. And I also knew that, what we were specifically interested in was the girder structure. So I was crawling right down, getting the camera down, into those, into the nether reaches that were hard to see. If it just been a question of getting the engine, you leave the diamond plate on and do a loop. That would have been a better way to go. But in this particular instance, I felt it was better to just do it side by side.
Sure, and I'm sure the scale bars help with that as well. Next question here that I can address a little bit, and Josh, feel free to chime in. Noted that there was a little bit of noise, or more so some stray points in the scan. And are there circumstances where you would spend time cleaning this up prior to bringing it into Navisworks? And there definitely are circumstances where you can do that. It's something that can be achieved, right on the tablet in Dot3D even, if you want to quickly get rid of the extra data. But my guess is in this case, it may not have even been necessary, and that Josh, had the information that he needed without having to, do any cropping or cleanup. But it is something that you can do by all means.
Yeah, that's right. We had the data nice and clean in the area of concern there. We easily could have cleaned out some of the outlying parts. If we were going to do a nice presentation report where we wanted a little bit nicer presentation, yeah, we could have spent some time cleaning out the extra points, but it wasn't hurting anything here, so we just left them in.
Definitely. Next question here is if the scale bars are required. I think I can answer that too, as applying to all of our scans. No, they're not, but they're recommended when possible. So it doesn't always have to be a hardware kit like what Tom used. It can also be 2 paper targets and a measurement with a tape measure or a laser disto. But especially if you're talking about the end-to-end measurements as opposed to the closer, more short-range measurements, which are always going to be very accurate on their own. It's a nice option to really give you that added confidence and tie them in extra tight to make sure that you don't have to make any return trips to the job site.
We use these systems in other markets. One of the applications for our technology is mapping crime scenes, and there, if the data is going to go to court, which it has, it's very helpful to have an external reference that everyone understands. These scale bars can even be acquired with a NIST traceable certificate, so they can be traced back to the standard SI meter. It's a little bit extra for that capability, but certainly can be done. So, it really depends on the application. We get very good data without the scale bars, but just the highest confidence, best data comes with the scale bars.
Definitely. And on that note, one more question about the scale bars that I can address quickly. Are spheres with a known diameter ever used instead of a scale bar? Not currently. Right now, what our software is supporting for this auto recognition of these targets and these bars is a flat target, whether it's a hard target like Tom used or a paper target. It is a flat target, and it is a special target. We can utilize standard checkerboard targets, standard survey targets, but we have an even more automated workflow with what are called April tag targets, where it automatically recognizes these unique target IDs And all you have to really add in there if you're doing it manually is the distance, or in this case, when it's with the Brunson scale bar kit, there's actually no manual input required at all. The software recognizes it all automatically.
So with that scale bar, we're getting of order of 3 to 5 millimeter accuracy, inside the scale bar range, and locally, of order of 2 millimeters, so it's that kind of accuracy. We're not sub-millimeter. This is not a high-end ZNF scanner. It's it's an inexpensive handheld scanner, and you trade off accuracy and speed of data collection and ease of use and interoperability with other solutions. So happy to have a longer conversation about accuracy, in follow-up.
Definitely. And I know this was touched upon a bit, in terms of the value of the handheld scanner to share the data with Josh in real time. The question is how the files were transferred from the field in real time.
Yeah, so I set up a hotspot on my phone and then loaded the data to a Dropbox account from the engine room. So just, from the scanner, there's a button, you hit share, and it'll send it directly to Dropbox. So we uploaded it to Dropbox, took about 4 minutes to transmit the file. And then I texted Josh and said, okay, I just got notice that it's been sent. So it's available to you. And I sent him the link and he was able to download it from there. We sent the file in the DP format because that's the most compressed file format. If we'd sent it as a recap file, it would have been 13 times larger. So we like to send the data around as DP files in our very compressed file format.
Perfect. And that answers another question about which file formats were used. Probably have time for one more here. So Tom, the question is, how long did each scan take and how long, were you on site in total?
So we were on board the ship for about 2.5 hours. And the first hour and a half was sorting out, some of the deck plate, the diamond plate had to come up. So sorting that out took a little time. So the actual scanning itself was probably 45 minutes or less. And then there was some time when we sent the data and had it reviewed by Josh. So there was a little bit of dwell time there. But numbers like that, if we were doing a second one, I think we could be in and out of there in an hour. But, again, you never know exactly what you're going to encounter when you show up. And getting the deck plate up, the diamond plate up, turned out to have a few challenges. There had obviously been some modifications made to the engine equipment after the diamond plate had been installed because it didn't just lift up, it had to be cut out.
Great. That covers it. We have a few more here, but we'll be following up, like I mentioned earlier, with everyone who submitted questions, for those we addressed on the line and did not, with more information. And then you all will also be receiving a full recording of this presentation within the coming days. So I'd like to thank Tom and Josh and for everyone who joined us on the line today. If you have any more questions, please feel free to respond directly once that recording is set out, and we'd be happy to answer them. Thank you and have a good day.
Thank you so much, everyone. And big shout out to Josh for helping us with this. Thank you.
Yep. Thanks, guys.
Thank you.